Let's take a look at the solution for this problem. We want to take and find the critical points and then use the second derivative test to determine the relative extrema. In other words, we want to find whether or not each of the critical values results in a relative maximum or a relative minimum. Let's do our standard thing. Let's find the first derivative and the second derivative. The first derivative is 3x squared minus 6x minus 45. The second derivative is 6x minus 6. If I'm looking for critical points, I first need to find the critical values. I do that by setting my first derivative equal to 0. I'm going to divide both sides by 3. I can factor the right-hand side into x minus 5 multiplied times x plus 3. And that gives me 2 solutions, or that gives me 2 critical values. The first critical value would be x equals 5. The second critical value would be x equals negative 3. For the sake of completeness, I'm just going to write the critical points. If you plug in a 5 into the function, again, you're plugging in 5 into the original function. I ended up with 5 comma negative 165 as my critical point with x value 5. My critical point with x value negative 3, when I typed that in, I got an output of 91. Again, typing that into my original function, I got an output of 91. Therefore, negative 391 would be the critical point on with x value of negative 3. Let's use the second derivative test to see whether these 2 points are relative minimums, relative maximums, one of each, both not, all kinds of things. Second derivative, when you plug in a 5, is equal to 6 times 5 minus 6. 6 times 5 minus 6 becomes 24. The key thing there is that that's positive. So we know when we have an x value of 5, we're concave up. Concave up means we have a relative minimum at the point 5 comma negative 165. The second derivative, when we plug in negative 3, 6 times negative 3 minus 6 is a negative 24. Key thing there is that it is negative, so we know our graph is concave down, which means I have a relative maximum at the point negative 3 comma 91. So we have 2 critical values, and now using the second derivative test, we can tell when the critical value is a relative minimum and when the critical value gives you a relative maximum. Obviously, we've seen also an example earlier where the critical value gave me neither a minimum nor a maximum.